Roots and radicals multiply. When multiplying roots or radicals, the index must be the same in order to multiply. I choose to multiply what is under the radicals, that's called the radicands, first, and then simplify. Look, it's okay if it's possible to simplify both or either individual radicand or what's inside the radical first, then that's okay as well, all right? But I want you to understand if you do that the radicand from the resulting product might need to further be simplified. Here's my disclaimer. For the purposes of this video, I will assume all variables represent positive values. Please understand that variables can be negative, so if your book or class does not restrict the variables to positive values, then you must remember the property that states absolute value of a squared, absolute value of a squared equals a for any a, all right? This is actually true for any even root of a variable resulting in an odd power, all right? Depending on how the problem starts. For more information about if negative values of variables are possible, then watch my video, Roots and Radicals Negative Variables. So here, let us multiply, let us simplify this. The square root of 3 times the square root of 6. Again, I'm going to say, hey, these are both under the same one. If there's nothing written there, they're square roots. This is the square root of 3 times 6, which is the square root of 18. And then I'm going to take 18 and say, okay, what can I do with 18? Is 18 a perfect square? No. Is there a perfect square that divides into 18? And the answer is yes. 9 times 2, right? So I'm going to take this into 9 times 2. And the reason I do that, the square root of 9 is what? 3. And what stays under the radical of the square root? The 2. Because I can apply the square root to 9. The square root of 9 is 3, but I cannot apply it to 2. I have to keep 2 under the radical. All right? So we're going to multiply. I'm going to multiply it first and then simplify. And if you need help simplifying, then go to my Roots and Radicals Simplify video. All right? That will help you see what we just did. All right? Where I go into that in much more detail. So here, the square root of 8x, I'm going to do this one over here, times the square root of 10y. Again, they're both square roots, so I'm going to say the square root of 8x times 10y, which is the square root of 80xy. And then I say, wait a minute, can I break 80 up into the perfect square, a perfect square times something? Well, 4 times 20, but wait a minute. 20 is 4 times 5, so I can go further than 4. I want the biggest one. 9 does not go into 80. 16. What is 16 times 5? 10 is 50, and 6 is 30. 15 is 80. All right, so 16 times 5 here works. 16 times 5. The square root of 16 is what? 4. And under my radical, there's a 5. Now, notice I didn't leave space this time because if I look over here, my x and y are both to the first power. And my index is a 2, so if my powers are smaller than my index, the x and the y cannot come out. So that is just going to be 4 and then times the square root of 5xy. So 4 square roots of 5xy. All right, let's look at the next one here. Square root of 20x times the square root of 5x. In this particular problem, because the 20 and the x are under the radical here, the square root, the way that these things work, this x can only be positive. Even if I didn't in this case say let it represent positive, it has to be in this case because you can't take the square root of a negative x and the 20 is positive, so the x has to be a positive value or this won't even work. So in this case it doesn't matter, but in other problems it might, so that's why I have my disclaimer. So here I'm going to say this is the square root of 20x times 5x, which is the square root of 100x squared, right? 20 times 5 is 100, x times x. We add the exponents of 1 and 1 and get x squared. So then the square root of 100x squared is 100 a perfect square. Yes, indeed it is, right? So this is going to be 10, and then 2 goes into 2 one time with none left over. So here, this was a perfect square all around. There was nothing that was remaining to be put under the radical. 10x came out and nothing was, no numbers, no variables were left under the radical. So that was simply 10x. All right. So here the next one is just going to get a little bit bigger with x's and y's. I'm going to say this is going to be the square root of 5xy times 10x squared y. So that's going to be the square root of 50, and then x times x squared is x to the third. We add the 1 plus the 2, and then the y to the 1 plus 1 is y squared. Y squared. So I'm going to shorten that up just a little bit. All right, and then here can I break 50 up into a perfect square? Because 50 is not a perfect square, right? 49 is, and 64 is, but 50 is in between and it's not. So is there a number that I can divide 50 by? Does it help me to do 5 and 10? No, because I can't do 5 times, or square root of 5 or the square root of 10. But it does help me to do what? That's right, 25 times 2. Why did I do 25 times 2? Because the square root of 25 is what? 5. And then under my radical, and this time I notice these powers are big enough with the 2 there to bring x's and y's out. So I'm going to leave some space for those things here, right? So 5, and then the 2 stays under the radical. And then, right, because the square root of 25 is 5, square root of 2 we can't do, bring it under the radical. Now 2 goes into 3 how many times? 1 time with 1x left over. And then what about y's? 2 goes into 2 how many times? 1 time with none left over. So there are no y's under here now, okay? There's no y's under there now. So 5xy times the square root of 2x. Let me shorten that up a little bit, and that's my final answer here. There's nothing else I can do to that one. All right, so multiply them is just literally, I just multiply the radicands, what's underneath there, put it under the same root, because it's got to be the same root to start with, and then I simplify it. So here, cube root of 6x to the 7th y times the cube root of 9x to the 4th y to the 12th. Again, they're both under cube roots. They're both under cube roots here. So that means I'm going to put them under one big cube root. And say 6 times 9, let's see, 6x, I'm just going to write it out like I've been doing. Although you can skip this step, many of you will. But remember my philosophy on skipping steps. I've told you this in just about every one of my videos. You're not watching this video for fun. You're not just hanging out on a rainy day or in the midst of whatever's going on and going, man, I just wish I could watch math videos. Let me go find some crazy guy that's talking about math. No, that's not what you're doing. You went out there searching for videos, and hopefully you found mine and you like them, and they say and they help you, and so you keep watching mine to try to figure out what you're doing in your class if you're lost on something, and you're looking at this going, well, right? If you're in that camp, because that's probably what camp you're in, you probably have a test coming up on this. Don't skip steps if you're going to miss it. That's my philosophy on skipping steps. Don't do it. Not if you missed up. Now, if you learn that you can skip a step and still get it right, that's okay. Skip it. But don't be insane. Don't keep skipping the steps if you keep missing stuff. Show all the steps. All right? So here, 6 times 9 is 54. X to the 7th and x to the 4th, we add those. 7 plus 4 is 11, and y, and we have a 1 here. 1 plus 12 is 13, and that stays under my cube root, folks. Right? I have not applied the cube root. A lot of times students get, I multiplied and I'm done. No. And if you want to put this in parentheses, by the way, for multiply, you can. I chose to put the dot there, okay? But don't just multiply that and get 54x to the 11th y to the 13th and think you're done. You still have to take the cube root. Is 54 a perfect cube? And the answer to that is no. So what I'm going to do is break that up into 27 times 2, because 27 is 3 cubed, right? The cube root of 27 is 3. So that comes out as 3. And then if I glance at this, before I write my cube down, will I have any x's and or y's come out? Yes, because both powers are bigger than my index of 3, right? 11 and 13 are both bigger than that 3. So that means that I will have both x's and y's to put right here before I get to my radical. So let's come over here and say cube root of, what's left over so far? Well, a 2, right? Then I get to my x. 11 divided by 3. 3 goes into 11. Right? If we think about that as a mixed number, 3 goes into 11 3 times with 2 left over, 3 2/3. The 3 that it comes out is this that comes out, x to the 3rd. The 2 that are left over are left in the radical, okay? And then the same thing with y. 13 divided by 3, there's going to be 4 y's that come out. That's 12 of them with 1 y left over. So 3x to the 3rd, y to the 4th times the cube root of 2x squared y, and that is the final answer for this one here. All right. Can I multiply the next one? Well, sure, they're both what? 4th roots this time. They're both 4th roots. So this is going to be the 4th root of 4 times 8, which is the 4th root of 32. Is 32 a perfect 4th power? Now, remember, I gave you all those squares and cubes, and I gave you 3 other things to remember. One of them was 2 to the 4th is 16. 2 to the 5th is 32. and 3 to the 4th is 81. And we talked about other things bigger than that, but those are the ones I said you need to kind of commit to memory. You'll see them again. Well, here it is. This we are going to break up into 16 times 2, because the 4th root of 16 is 2, and then the 4th root of 2, this 2 stays under here, okay? This 2 does not come from that 2, no. It comes from 16, because the 4th root of 16 is 2, or 2 to the 4th equals 16, okay? That's where that comes from, all right? So, what if I wanted to distribute? I'm going to have distribution here, and then guess what? We're going to also FOIL, okay? So what if I distribute here? Well, I'm going to take the square root of 3 and distribute it to these two things. So I'm going to show my distribution on this first one, and then I'm going to just skip that step on the next one. This is going to be the square root of 3 times 5 minus the square root of 3 times the square root of 3. I call that showing my distribution, where I have my distribution of square root of 3 times the two terms, and I went and wrote it down. Typically, we don't do that, but when it's radicals like this, sometimes it gets a little confusing, so I will show my distribution at times. Here, I'm showing it mainly to show you what's going on. I may continue to do that, but we may just have to keep up with it in our minds, just know what's happening here. Can I multiply that 5 and 3 together? No, because the 5 is not under the same radical. In fact, it's not under a radical at all. So this is going to simply be 5 square roots of 3, or 5 times the square root of 3. Just like you took x times 5, you get 5x. Same thing here, 5 square roots of 3. Minus the square root of 3 times the square root of 3. Yes, in fact, that's a nice one, because I don't even need to go to the square root of 9. I just need to drop the square root, right? Square root of something times square root of something is something. So this is minus just 3. And then, are those like terms? No. Remember, to be like terms, you got to have the same radical. There's no radical in that second term. So 5 square root of 3 minus 3, and you're done. There's nothing else to do this one. Okay? You are done. So I'm going to distribute here as well. Okay? I'm going to show the distribution again, just so you see it. Square root of 6 times 4 square roots of 6 minus square root of 6 times 3 square roots of 2. So here, this gets multiplied. It is not a distribution. This is all one term. Do I multiply this times the 4? No, they're not under the same radical. So the 4 is just out front, and then I multiply those two things. What is the square root of 6 times the square root of 6? It is 6. And why did I put it in parentheses? Because the 4 is times that square root of 6, right? It's out front. It's times it. So how do I represent times with 4 times 6? Either with a dot or with parentheses, and I chose parentheses here. Minus this 6, again, doesn't go with that because it's not under radical. There's a 3 out front. But I multiply it here, and I put it all under the same radical, and 6 times 2 is what? 12. Right? The reason I didn't put this under a radical is because I had square root of 6 times square root of 6. Anytime we multiply the square root of something by itself, the radical just goes away. All right? So now we have a little work to do. We have 4 times 6 is what? 24. Minus here, this is going to be 4 times 3, right? So I have the 3 I bring down. What do I do with this 4? It comes out as a 2 because the square root of 4 is 2. I'm going to bring that out front. I like to underline what I'm bringing out. And then what stays under the radical? This 3 here, right? That 3 stays under the radical. So there's one more step to do here, and that's to multiply my 3 and my 2 here, right? So this is going to be 24 minus 6 square roots of 3, and I cannot do anything else with that. Those are not like terms. I can't simplify the square root term anymore, the radical term. So I am done with that one. All right. So this is the step. If you can do this step in your head and skip it, that's fine. But again, if you're missing problems when you try to skip a step, don't. Just don't. Like, I don't even like to talk about skipping steps because everybody in algebra wants to get through quickly. Okay. You got no patience. That's one of the things that math does for you. It helps you with your patience. Okay. Some of you are like, no, it tries all mine. It takes it away. To get better at it, become a Jedi and exercise more patience. Okay? So here, 2 terms times 2 terms is FOIL. FOIL. First, so let's do that in brown. 4 times 3. 4 times 3 is 12. And then I'm just going to change colors for each one of these. Outer, outside, 4 times negative 5 square root of 7. The 4 and the negative 5 are not under radicals. They can be multiplied. That's going to be negative 20, and then tack on the square root of 7. That's like negative 20x. Okay? And then for the inner, we'll do this in yellow. This one right here. The square root of 7 times 3, they're not under the same radical, so just plus 3 square roots of 7. You can't do anything else with that. And then finally, last, plus times a minus is minus, and then there's nothing out here but a 1 times this 5, right? So the 1 and the negative 5 make negative 5 when you multiply, and then you multiply square root of 7 times square root of 7. That is 7. And what are you doing with these numbers here? It's not negative 57. You're multiplying them. So either put a dot or put it in parentheses, which is my preference here, okay? To remind me, hey, I'm multiplying those together. So if I start to work through this, this is going to be 12. Those two terms are alike. They are like terms because of the square root of 7. So then negative 20 plus 3 is negative 17 square roots of 7, right? 20 minus 3 is 17, and 20 is larger than 3, so we keep the sign of 20, which is negative. And then minus, if we multiply those together, we get 35. And there's actually one more thing I can do here, right? I can put this term with this term, 12 minus 35. Okay? 12 minus 35, again, 35 is bigger. 35 minus 12 is 23, and it is negative. And then minus 17 square roots of 7, and that's it. You can't do anything else with that one. Okay? So we foiled. I did brown, green, yellow, and gray there, trying to separate them out, although some of those colors are really close together. All right? And then we just have like terms. And when we end up, this last one turns out to be one like the first term once we simplify it to negative 35, and then we can combine it with that. All right? So let us do the same thing here with this first, outer, inner, and last. What is first going to be? 7 times 5 is 35. And then outer, 7 times negative 3 square roots of 3. 7 times negative 3 is negative 21, and then square root of 3. In the middle here, inside, negative 2 square root of 3 times 5 is negative 10 square roots of 3. And then last, negative 2 square root of 3 times negative 3 square root of 3. So we can take the negative 2 times the negative 3 and get a positive 6. And then multiply by what? What is square root of 3 times square root of 3? Times just good old 3. Right? And if you want to, this is how I skip a step here. Okay, and again, I don't like talking about that, but I'm going to write it down, though. See, I'm not just doing it in my head. I'm going to say plus 18 is what that becomes. So now I can take this term and put them together and then put these terms together. So 35 plus 18. And the way I do that in my head, I do 35 plus 20 minus 2, right? 18 is 2 away from 20 on the lower side. So if I add 20, I get 55, and take 2 away, I get 53. And to me, that's a lot easier to do in my head than trying to go 18 plus 35. 3, carry a 1, 3 plus 1 is 4, plus 1 is 5. I just add 20 and take 2 away. So 53, and then both of these are negative, right? So you add them. 21 and 10 is 31, and it stays negative. And what made them like? Square root of 3. So like terms, when you combine them, you get a like term. So you combine 2 square roots of 3, you get a square root of 3. You don't get anything else. All right? So that is that problem there. All right? We cannot combine those. They are not like terms now. All right, and our final one. All right, 5 minus the square root of 2 times 5 plus the square root of 2. Now you'll find out in the division and rationalization or rationalizing video that these things actually are called conjugates. So I'll just introduce that word to you here in case you have never heard it before. Notice the 5 is positive in both, and the square root of 2 is negative here and positive here. It is a conjugate if everything is the same except one sign. It doesn't have to be the sign in between them, but one of the signs has to change and the other one does not. So the 5 doesn't change here, but the square root of 2 does change, so these things are conjugates. Whenever you have radicals involved, the conjugate is an important concept, and also what happens when you multiply conjugates is important. So I want to show you here, just give you an example, not a rule here, just give you an example, and I'll tell you what always happens, but just let you know with an example here to see it. So we're going to do first, and then outer, and then inner, and then last. So 5 times 5 is 25. And then 5 times positive square root of 2 is plus 5 square roots of 2. And then here, negative square root of 2 times 5 is minus 5 square roots of 2, right? We can't multiply those 5 and 2s because The 2 is under a radical, the 5 is not on both those, outer and inner. And then a negative times a positive here. What's a negative times a positive? Well, it's minus. And then square root of 2 times square root of 2 is, that's right, 2. So we have here, these two terms go together, and then this goes with this. So 25 minus 2 is 23, and these things cancel. Plus 5 square root of 2 minus 5 square root of 2 cancel. If you multiply conjugates, the middle terms always cancel. It's really nice because when you multiply conjugates, you get an answer that no longer has a radical in it. Isn't that glorious? Did you hear what I said? You get an answer that no longer has that root or radical in it. You don't have a square root anymore when you do this. Okay? Now this works with square roots in two terms. Okay? Something called a conjugate. You write down the two terms, and typically we change the sign in between them, but it can actually be either sign can be changed. All right? So I hope this helps you in multiplying roots and radicals.